Thank you all so much for joining us today. So let's get started. We'll talk about multi-agent systems. Maybe with a show of hands, if you can share if you've heard the term multi-agent systems before. Okay. And then maybe if anyone wants to share, what characteristics are there in multi-agent systems? What do you guys know a little bit? If we can unpack that a little bit. Any brave souls out there who can say something about a property of multi-agent system?
Your agents can specialize for specific problem sets.
Your agents can specialize for specific problem sets. Okay, great. Anything else? Yes?
Agents are usually local and don't have global influence.
Okay, agents are usually local. They don't have a global influence. Okay. Anything else? So this is how we're defining an agent. There are articles and publications on what is an agent, and everyone has right now a different take on it, and sometimes they talk about specific aspects of it, but what we're doing here is just really putting together a cohesive picture of what we're thinking of as an agent, right? So an agent, it's, as you had said, a specific problem set or a goal, right, in a specific environment. So, right, so not global, but there's this local environment, something that they are catering towards. And they have sensors and actuators. Those are sensing, so those are inputs from the environment, and actuators are outputs to the environment. And then you also have within an agent, and this is actually a big differentiator from maybe any other software module you might build, is that agents have their own decision engines and their own self-learning power within them. And then, of course, there's communications to human agents, to other machine agents. Then there's a control panel that will also allow people to administer, observe the agents and how they're doing. And then agents might have their own local memory as well as a knowledge base. So any questions on that? Does that make sense? Is that cool? Okay, so this is going to be the definition we're going to use, and this talk is not just about single agents, but multi-agents. So you can now think about that microcosm now becoming a macrocosm with multiple agents. So within now, the yellow box, you're seeing within it multiple agents interacting with each other. From a black box perspective, though, perimeter outside it, still similar things, right? You got the sensor, actuator, you got the knowledge and memory and communications and control panel, and then once again, collectively as multiple agents, they have that problem space or that goal that they're going after, right on the left. Now, there are different ways that those multi-agents might interact with each other. They might cooperate, they might compete, they might negotiate with each other, and so forth. So those are things that we'll unpack a little bit also in this talk. So are you guys all with me? Now, another way of also thinking about a maturity as you guys are thinking about agents that we might build or agents that you see in the world, there's that single agent. We talked about multi-agent, and multi-agents here, you know, the first order of thinking when it comes to multi-agents are multi-agents that have, they might share a context with each other, to collaborate with each other. There are ways then to discover what are the agents in the system. Then there are ways for those agents to interact, as we said, and they will then need a communication language to be able to communicate with each other. Then if you go one order beyond that, you could think about having not decentralized agents. Now there's a little bit more of that, you know, topology where there's peer-to-peer, there's a more distributed nature where you don't have a hierarchical tree for anymore, right? So now there's agents that are even more empowered than perhaps they were before. Before it was a hierarchical, centralized way of, you know, delegating or communicating what to do. But now it's more decentralized, you're self-empowered, and therefore what it does come with additional complexity. So now you have distributed decision-making, you have even more complex communication protocols to allow for that peer-to-peer. And then the higher level, even beyond that, is now you have a supermind with human agents and machine agents all collectively working towards some complex problem. So did you want to add anything to that, Samia, before we go on to the rest of the talk?
I'm just curious, what's the value promise here? Why should I think about agents?
Okay, great question. And so this is just a glimpse of what we are going to cover now in the rest of the talk after that intro. We'll talk about that promise as Samia was questioning. We'll go through a few examples of agents to really make this a little bit more concrete. What are some classification of agents? How do you guardrail those agents now that there is their non-determinism and autonomy and so forth? And how do you get started? Okay, so first, what's that promise? Now, we could think about multi-agent architecture as a paradigm. It's a paradigm shift in some ways of thinking. So, but whenever we have a paradigm, it's not just like, oh, think about the benefits and just go after it, right? It's if we fulfill these conditions. So a paradigm to be successful needs some base conditions. And then you have those benefits. But with those benefits are some trade-offs, so some costs that we need to be able to be open to accepting. So what are some paradigms that you guys might know of, some paradigm shifts that might come to mind? Okay, so like asynchronous ways of thinking, right? So like a lot of the messaging paradigm as opposed to more, yes, okay. So like even a declarative versus imperative way of, okay, programming, good. Functional programming as well, yes. So what, because we're at LambdaConf, so what would you think are those conditions that need to be met so that we receive the benefits and then we have to accept the cost of functional programming? So here's our take on that, right? On the left here you see microservices and its promise. On the right here you see functional programming and its promise. So for functional programming, if we structure our code using pure functions, it's, without, and avoid shared data, avoid mutable data, and avoid those side effects, then you have this benefits of easier debugging and so forth, more predictable outcomes. But what's the cost is that it is a different level of thinking. There is a steeper learning curve. So these are things that as a society or whoever is adopting these paradigm shifts would need to overcome. Now, similarly, for multi-agent systems, right, we would want to think about this and what's the promise of that. And so here's our take on it. If we implement these this is a very brief way of describing the multi-agent system, but this distributed, communicative systems with self-learning, intelligence, right, that decision engine capabilities, and being able to now leverage Gen AI and the modern hardware, because without which we wouldn't have really been able to continue to accelerate this, then we can really have, so answer Samia's question, the value. Now we can advance the human-machine collaboration to innovate and solve scalably and sustainably more complex and adaptive problems of society. By adaptive here, meaning constantly changing and moving forth and really coming together as that supermind, but even a multi-agent, even without the human, in that there's a lot more complex problems we can solve. So, but what does that come with? So we have to be mindful of the additional complexity and the added responsibilities that we have, because we have to make sure then we have those guardrails in place as well, because otherwise, yes, there will be those unintended consequences. So let's make this concrete. Samia, could you walk us through some examples?
Yeah. Now that we have a definition, I'm curious, do ideas or real-life examples pop up in your mind about multi-agent systems? Does anyone want to share?
Yeah, sure. Yeah, so at our company, like, we work with like on this LLM system, and we come in, and the LLM is reasoning about what tools to use in order to like solve this problem provided by tools. But what part of the issue is that like as the growth of tools expands to get added functionality, it becomes hard to pack it all into one agent. And also maybe the agents want to have different goals, like hey, this specific agent wants to help the user in this specific way, or each, like, especially as a company grows, maybe hey, this specific team wants to configure their problems in a specific way. So like that's why we explored like in this, I didn't even realize there was a greater context of multi-agent, but in the context of LLMs, multi-agent systems.
Yep. Just to play back for the audience, for the recording, you were talking about lots of tools out there and using LLMs to capture the different goals and the value of those tools and allow that adaptability as newer tools come forth within your team and your company. Multi-agent systems have actually been also used in the last couple of decades in if you're a gamer, StarCraft 2. I haven't played it myself, but that's there's a lot of non-determinism, and the goal there is you have opposing teams with coordination and management of individual units. There are different agents, so you have humans, obviously, then there's the Marines, the Zealots, the Zerglings, each with their individual goals. And then over here, the interaction model, which Nimisha showed in her architecture diagram, has there can be different interaction models. In this case, there would be cooperation for folks that are going to partner to beat the other team, and then there's going to be the competitive nature. Another great example of a multi-agent system is our Amazon delivery system and how they do their warehousing of efficiently moving packages from storage pods to all the way to order fulfillment. So they purchase Kiva Robotics, and in there, the system is designed with these autonomous agents with obviously your human workers having full autonomy. Then you have your driver units, which are the orange bots you see in the diagram or in the picture there, and then your inventory station agents, which are not here, but they're really sorting the inventory and arranging what is going to get shipped and loaded into these driver stations. And then the interaction model in this warehouse is obviously going to be cooperative. My favorite is the smart grid system. This has been in design and in execution for, I would say, the last 20 years or so. Colorado has attempted at it. I'm from Chicago. We've actually made lots of headway in the form of getting smart meters out there. The goal over here is enabling efficient, reliable, and sustainable energy management. And there's a lot of autonomous agents, right? All the way from your grid operators, the way the energy is being transmitted from your renewable energy producer to the consumer in a household, and also allowing for consumers to becoming prosumers. So I can have my solar panels at my home and give that energy back and get some savings for myself. And then the interaction model is cooperative. All these three ties back to that value promise of we are allowing for that scalability, non-deterministic systems where we can't really codify every little detail or predict every little thing. So each of these things, the grid operators, for example, will have a decision engine and a learning engine to learn about when do systems fault or when producer consumer is out of energy, and then they give you alternative energy from another producer. So those are some of the examples, and we will look at something that will help our brains working around exploring the Jetsons as a multi-agent system. I don't know how many folks in this room have seen the Jetsons. Okay, a few head nods, few hand raises. It kind of gives your age away. I never thought I would say this in my lifetime, but I guess I'm at that age. I watched this in the 90s, and as a first-time mom, I have all these problems of I need someone to clean my place. So there's Rosie the robot that cleans up after George, who's one of the main characters, who's eating and making a mess. So Rosie's cooperating and cleaning up after George. And then there are autonomous flying vehicles in this future world. And in that vehicle, you'll see Judy Jetson, I'm trying to remember the characters, Rosie the robot, Astro the dog, and Elroy the little baby in its own pod getting dropped off to its school, which I think is pretty neat. As a mom, when you're dropping off your baby, it would be so nice that you don't have to pull up and then take your baby all the way in. You can just, at the click of a button, drop them off. So with that kind of story landscape, I'll open it up here. What are some of the agents and goals that you spot here through these three visuals?
So
So playing that back on the mic, Rosie's goal is to keep the house clean, so that is a goal. And then the drop-off mechanism for Elroy to the school and making sure it's safe and he's being dropped off on time are some of the criteria for these agents to work together and make sure that they are cooperating and functioning appropriately. So with this stage setting, I will hand it back to Nimisha to explore some of the aspects of multi-agent systems.
So let's classify the multi-agent systems a little bit. We'll go through a few different examples of dimensions. Now, this is not a comprehensive list, but just to, because it's sometimes nice to kind of think through these different categories to just get your mind thinking about, oh, okay, I can think about the multi-agents this way and that way. And then when you design your multi-agent systems or use any of them, you might think about it a little bit more deeply. What is that agent? How do I design for it? So the first one is the topology types. We talked a little bit about this, of the centralized multi-agent architectures versus the decentralized, and the centralized would be a little bit more orchestrated and decentralized a little bit more peer-to-peer, more mesh-like. And now in the example of Jetsons, right? So we have the centralized one where you do want to be a little bit, you want to make sure that checklist is there at drop-off time. Did my kid have the lunchbox with them? Is it safe? Did they get their homework? Do they have their backpack, their water bottle, all that stuff? You know, that seems to be good to just make sure you have a pretty good, robust checklist and orchestrating that. But then there are things like the autonomous cars and the drop-off pods. You don't want to necessarily centralize too much of that. You want it to have a little bit more of thinking through, of connecting with the other peer agents that it runs across. There's some more collaboration because each drop-off point might have its own, on-ramp and things like that. So there's a little bit of learning and so forth, especially with autonomous cars as well, with autonomous cars communicating with each other and things like that. I guess in Jetsons it's not just cars, but autonomous flying vehicles as well. Now another dimension is interface types. So I'll go through first too quickly here, but there you're thinking about, is this agent, does it have a human interface? Or is it just really headless, just like you might have, a Chromeless browser type of thing, right? So that classification also then implies how you choose to implement it, how you're going to test it, how you're going to think through then its interaction modes. Now, in the case of Jetsons, you can think about for the human interface, right? Rosie, the robot, right? She will have her verbal interactions and her physical interactions, her arms up, or her facial interactions. All of that is interfacing with the human agents. And then there will also be some communication she might have with other bots, with other, bots that might be in the household and things like that, which doesn't need that human interface. But as soon as machines start to interact with humans, and why this is an important dimension, is you have to make sure you have that right semantic layer. You want to make sure that you're also thinking about the human-centric nature and human emotions and human reception to that interaction. So it, changes the way how you think about designing your agent there. The third one is a little bit something I want to introduce here. I haven't read about this, but really having meta agents as well as the non-meta agents, lack for a better term here, but the meta agents are the ones you can think about that are cleaning up, that are making sure that the agents that we've built have the right governance, have the right compliance. So they're not necessarily addressing human tasks maybe, or specific other problem spaces, but their problem is to make sure all the other agents are on track, right? So that's another classification. So here in the Rosie example here, right, you can think about those meta agents when you're programming or building Rosie. It's a self-learning, yes, bot, and will make her own decisions, but what are those guardrails? What are those things? We want to make sure you respect the neighbors, or use respectful language when you're interacting with any human. Protect our family privacy. May not know that. What does privacy look like? These are things you might need to make sure that Rosie's, interactions are guarded. And you can do that through an agent. right? It doesn't all have to. So because that you can, over time, learn. There will be reactions to perhaps sometimes there is a family privacy breach, because that happens. Even as human agents, we sometimes reveal something that we shouldn't have. Oh, shoot, that was a promise I broke. You know, I wasn't going to tell or whatnot. So by even thinking about this mentally as not just a programming rule, but a privacy agent, then you can evolve and learn. And then I think, okay, interest in time here. So home chores, for instance, though, that doesn't necessarily have to be that is a user task. Another classification is thinking about the replication types. Here too, by the way, as we're going through this, think about the parallel in the human agent world, okay? So even for those of us who might be either managing others or being managed or just being a leader in the organization, are you thinking of yourself as an individual and the work you do? Are you also thinking about amplifying yourself, delegating to others? Are you thinking about, you know, spawning that next human or whatever it is? Are you building that next agent? So that also classifies how you then think about your decisions as well as your own learning capabilities. So here in the case of Jetsons, you have, when it comes to the task of building a furniture, maybe following those rules and learning also how to be better at building furnitures, you know, that's just an individual task maybe. But when it comes to like caring for a new child, if the Jetsons has a new child, now you have to adapt to just that specific child because each child is unique, and so the learnings of the past may no longer apply, and you also want to scale yourself. So maybe you spawn a new agent within Rosie, right? This is like within Rosie, who's a multi-agent system. She maybe spawns a separate agent within her. There's not like a human brain or anything, but just within herself of like, okay, this is the agent that's going to, you know, be really responsible of thinking about this child because this child is going to be a handful, you know, multi-handful on their own type of thing. And then the last thing is initiative types, at least the ones we have here. And here too, you can think about it on the humans, right? When are we reactive versus proactive, and where are those agents that could be self-initiated versus those that are responding to messages and signals. So here as an example, you know, Rosie could be proactive. She notices that there's a temperature increase in the mom's body, and so maybe she, you know, proactively serves breakfast in bed, proactively puts the, you know, soup together and things like that, as opposed to the mom saying, Rosie, can you please make some breakfast with me? Can you please give me some medicine? That type of thing. So these are some examples. Hopefully it gives you guys a flavor as you think through this. And then, any questions up to this point? And there are other dimensions as well that we haven't talked through, but anyway, these are some ideas. Now, I want to talk about, as we're innovating and thinking about these agents, what are those guardrails? What are those things so that we just don't go rogue? They don't go rogue on us. So in order to do that, let's go back to this diagram that we had initially about an agent. I mean, this is agent, but you know, within the yellow box, you could just think about multi-agents. It doesn't matter whether it's single or multiple implementing it. So what do you think, Samia, in terms of the system-level guardrails overall that would be important? We have safe on top there with secure, accountable, fair, explainable.
Well, as a mom, the number one thing for me is going to be safety, privacy, and if it's a machine agent, that it should be respectful in my household. So some of those things come top of mind.
Yeah. So these are like system-level guardrails that we want to make sure that are implemented and they're overall at the agent level. And you might have others. So what we'll do today, right now, is just go through some that we've come across. And I think over time, as we build more agents, as we use AI more too, we'll really need to adapt and see where is AI failing and then, you know, go through them. Now, what I'd like to do is one way of also thinking about testing this type of stuff and providing these guardrails is to think about the boundaries. What are all the boundaries in this system? So another one here is the goals, right? So as the goals are coming in, what are some types of tests that we can run to just make sure that it's fitting within expectations? So for instance, yes, go ahead. Right, so programmatically, right, so there's some tests that you can write to make sure, I didn't catch the end, but you mean to make sure, so here we're saying, let's make sure we don't drift from the original goal. Does that, yes, exactly. So because what can happen is if you build a bot or an agent for a specific purpose, but then that bot is being used for something not it's intended for, you can then just imagine the unintended consequences there, right? So this is, it's responsible. It's a self-responsibility that it programs for itself. Now, what about at the sensor level? What type of tests can it check for at that time when it's getting inputs from the environment? Yes? Yes, go ahead.
Calibration tests?
Sensor accurate? Okay, are the sensors accurate? Calibration tests, exactly. Yeah, good. Oh, okay. Anything else? Yes.
For me, it's not exactly sensors, but like given a mock, like input the sensors, the goals, and then what are the outputs? Like what are the actual actuators? What are the things that it does in response to a given input?
Yes, exactly. So, so these are what we had for the sensors and actuators, right? So let's observe and make sure observability, all the things that we learned from other good programming techniques definitely apply here as well. Are there any anomalous behavior in the inputs? Also anomalous behavior on the outputs? Are there things that are noisy or irrelevant from the sensors? Actually, that will lead to more quality output because the environment is so noisy, even just thinking about it from a human agent side, right? So it's like, okay, well, in order for me to do this well, I kind of need to just put everything out of my mind, right? Because my mind itself is noisy. So it's that type of thing and helping the agent, constrain itself. And so forth. And then, yes, calibration, we didn't call out here, and then on the actuator, yes, definitely the success measure is also there. Now, number 5 up on top for communications, these are communicating with other agents, human agents, machine agents. Here we can think about making sure identity access management is considered, the intent as well. And this too, right, just think about it. If someone says, hey, can you please put the chair over there, as an example. If you don't understand the intent, why they ask that, you might put that chair upside down and you might think that you will be responding in a way that wasn't why they actually asked for it, that type of thing. So similarly, making sure there's intent analysis that's well done, the communications back and forth, they're respectful, but also that semantic match, because once again, I tell you, hey, can you please move that furniture from here to there, but what does, or I don't know, I'm coming up with some examples here, but just making sure that when I say furniture, you know what I'm talking about it, not something else. So those types of things. And then here, lastly, just knowledge and memory as well. These are more internal, perhaps for the agent, but really make sure there are 2 guardrails on biased data, diverse data, the latest data, the relevant data, all of that are checks. Now, how do we actually go ahead and enforce these guardrails? This too, I'm hoping that as human society will innovate, as technologists will innovate over time. But yes, certain guardrails, you may want the human in the loop. And some other guardrails, maybe for scalability reasons and whatnot, you may want machine in the loop, and having machines, there will be different heuristics. Maybe it's consensus-based. If as long as 5 of the meta agents, for instance, agree on this, then, we're good. Or if 3 out of 5 meta agents agree on this, then we're good, that type of thing for majority or weighted and so forth. And it'll be a combination of both of those. So that hopefully gives you some idea of guarding this. And I think hopefully unpacking this through this way also gives you a little bit of idea of how agents can be built. So what we're going to do now is, Samia, I'm curious, where do you think we can start with all of this.
Yeah, let's flip back to your evolution architecture slide. So Nimisha had, remember, talked about how from a single agent that has that decision engine and the learning capability can then be scaled out to multiple agents, again, with that context sharing, discoverability, and interaction. Then you can go into decentralized multi-agent, and then hopefully to sort of a supermind where you're solving even the tougher and bigger problems. So let's try to apply, or how we can actually apply this in real life in maybe today's context, and apply to subscriptions. I don't know how many of you fall victim to some of the knowledge that's coming out in AI content or even programming languages, and there's a lot of clickbait. I end up subscribing and my inbox is flooded. I don't have the time to unsubscribe, and I end up paying a Google subscription fee for storage so that my email account can continue to hoard all the information, right? So that's a big burden on me. There's other forms of subscriptions, vitamin subscriptions, your video, your choice of entertainment platform subscription. So there's so many out there. So if we take that kind of a landscape, how could we solve for this subscription problem, let's say for Hulu, with a single agent? How could we implement or accomplish that today? Any ideas from the audience? Yeah. So yeah, canceling my subscription. So today in current state, I have to actually go find my profile, find the cancel subscription, then it'll bombard me. I'll go to the screenshot, it bombards me with, hey, I'm tempting you. Do you want to pause your subscription by X weeks? And I'm like, oh, now I have to learn where the continue to cancel button is. But what if using LLMs and chat agents, which hasn't really, there are a lot of platforms doing it, but it's not easily available on Hulu. They don't have that. But it would be nice to have, hey, I really want to get my subscription canceled. Go aggressive, don't be tempted, just get it done, right? And it's done. I don't have to bother. So there's the human interaction, and it's me telling this virtual agent to get it done instead of me clicking through some form workflow. Go ahead. Why would I want to? Well, if they want my, they can keep tricking me, but if they want to have my future business, right? Once I go through this user workflow, I'm going to be cautious and not be a return customer, right? There are actually multiple other external applications that help you manage your cancellation of subscriptions. So there are all these spawning applications that are specializing in just doing this. So this would be one way of approaching it. But if we were to kind of take that scalability problem, this is an article from Wall Street Journal. People are sick and tired of all their subscriptions. How can we actually solve for this in a multi-agent system way? And in this case, you can see that if I had a digital twin of myself, right, as an agent, then it could learn all my preferences, and I can have another agent that goes and unsubscribes from everything that I don't care for. So that would be an awesome way to solve for this. Multiple platforms, multiple mediums of subscriptions that are out there, and just getting it tailored to myself. So how could we shift from just multi-agent system to a decentralized multi-agent system and more of a human network-powered subscriptions? So I want to be this Zen person who's just chilling, and I don't even have to worry about making decisions on subscriptions. So ideas on what are some of the agents that would be in place here to make that happen?
Managing their subscription very efficiently, so you can learn from other people's, and you can apply that to yourself.
Exactly, that's what I thought of. So I, as a mom, I have other moms that I trust, right, in my neighborhood, my friend Nimisha, and I trust their preferences and their subscriptions or unsubscriptions, or even the products that they're getting delivered using for their baby, or the organic or non-organic foods and products that they're using for their household. And we have the same shared philosophy on how much we want to spend. So taking those collaborative preferences across my network, getting everything kind of tailored come to me, and I'm not burdened. So I've solved for getting burdened by subscriptions. Now I'm hopefully adding more human value to myself by getting more curated subscription through my human network. So exactly what you described. So taking that decentralized multi-agent system, so these are things we can hopefully, it's inspiring to see how we could accomplish this today. How could we take this to the next level of making it maybe a supermind and bring a total e-commerce paradigm shift? What would that look like? Where Hulu is not making me, or is making decisions of not building a bot. We're eliminating that incentive.
Could it be like a platform, like, you have these like life coaches? Could it be like AI-based life coaches?
AI-based life coaches, yeah, that could be what, no, are you thinking life coaches who are virtual twins of yourself?
Or just helping you along the way?
Coaches helping you along the way. Yeah, so hyper-personalized coaches who are guiding me through my e-commerce experience. That could be one way. I was also thinking about, I care about climate change or more energy efficiency, waste minimization. So could e-commerce paradigm shift happen where now the supermind is not just looking at, the profit and loss for what products are being built for the human, but also solving for the world and minimizing, I don't know how many orders I get from Amazon that I don't end up using and I have to go return it, right? So there's just so much waste happening there, from energy to the ingredients or the resources that are being used along the way. So those are things that a supermind could help solve for. And supermind, FYI, just comes from the MIT, they have an institute for supermind design, and they look at exploring how machines and humans can come together and look at different different industries to actually solve for the bigger and better problems. So hopefully this kind of leads you to thinking how we can solve for things in a more pragmatic way, and how we could start using the multi-agent system principles and the design patterns to make it more realistic. And go ahead, Nimisha.
I just want to add, like, this slide, right? What exactly is that e-commerce paradigm shift and what that's going to look like is unknown, right? Because we haven't built that supermind, and we're hoping that with the machines that have now been, with those machine agents, with those guardrails, that they may be now able to programmatically, like, follow as well. That can help take out maybe some of the human emotions out of the loop. We can actually even say, what are we actually aiming for? Like, right, Samia said, like the climate impact in addition to satisfying my consumer needs. But so what does that look like where, like, subscription doesn't even exist, right? And it's meeting our personalization needs. So that's why, like, we don't have a concrete answer to what that would be, but we do think that maybe evolving towards this. But hopefully you guys got a sense of, like, even going from single agent to multi-agent, and then what that could be. Yeah.
Do you want to close it out for us?
Oh, yeah. So in terms of final remarks, this essentially putting this all together really remind us, as we're building out these multi-agent systems, let's keep the value, right, first and foremost. And it is humanity at the end of the day that is building, evolving, and so forth. So what is that human value? And with multi-agent systems, hopefully we can tackle those higher order problems collectively. They are more complex, whether it's the environmental issues, profitability is such a key thing right now for us and the whole, economic situation that we're also at, and what are some new ways and novel ways of thinking that we could perhaps address, right, with the multi-agent system. And while we're doing that, let's keep the experience also in the loop when it comes to thinking about the human-centric architecture and human-centric design. There's a lot of opportunity here now, so it doesn't have to be that clickbait and the forms that we have to fill out, but it's once again, it's like if you're thinking agent first, you're thinking, what is that problem to solve? What is that self-learning? How are we continuously learning? And you're declaring that up front, as opposed to thinking, oh, it has to be this way. So it's no longer even imperative as much as declarative of like, hey, this is the goal, this is the end thing, here are the guardrails, now self-learn. And when you do that, there's an opportunity for our experiences with technology to be a lot more human-centric. So, because right now, people need to cater to the technology as opposed to the technology being able to serve our human needs. So goal first, self-learning first could lead us to that. And then finally, Samia, you want to talk us about human-guarded?
Human-guarded, yes. So like I said earlier, tests are going to be super important, and guardrails are going to be super important. While the value and user experience comes in play, things that could go wrong in this space is your agents could go rogue and use disrespectful language or talk to me in a language that doesn't even meet me. So if it's my parents, right? What are some of the tests or guardrails that I would want to implement in the language by which it's responding, and also catering to their specific needs. So to me, human-guarded guardrails and tests have to be a first-class thing. And then when you have family or humans in this ecosystem, there's safety checks, there is HIPAA compliance, there is privacy. Privacy is always top of mind, but there are all these regulatory bodies across the world that we have to account for. So again, you can think about when you are designing a multi-agent system, how would you engineer those in, as opposed to even just putting that in the human or making humans burdensome on doing those checks and balances.
So thank you all so much. I know AI is here, there's a hype and right now, but unpacking it hopefully helps it make it more graspable, but also allows us to see the opportunity and get us to where we want to go. So thank you all so much for coming, and we'll take questions. Yeah.
I noticed that you used the word non-determinism in your presentation, and can you elaborate on what it means in this context? Because like say in FP or functional programming, determinism is a good trait. So obviously in this context, non-determinism is a good trait, but I'm not very clear on what it means.
So, yeah, non-determinism, where this comes into play, and why it's even more important with the guardrails, actually, so much so, but also why it's also therefore the innovation and the art of the possible is also there. So by non-determinism, so the question was around non-determinism, and if we can explain that a little bit, because especially in functional programming, we're going after determinism. So, and typically, yes, as software engineers, we want the determinism, we want the replicability, so we have more confidence before we release something to production. But inherent in nature of things like generative AI, right? You are generating, and you are actually looking to innovate through those Gen AI capabilities. You're not asking, this is an example I've been giving, but you're not asking the question of what is 5 plus 3 to these agents. You're saying, write a math word problem, right? A math word problem that starts with 5. every time it's going to give me something new, and therefore it's every time it's going to give me something interesting and innovative and whatnot that I can then, share with others, and maybe it'll spark a new idea for me. So it's non-deterministic inherently as a result. And so AI models and other things that we also build, right, will also have those capabilities. So I think, so that's where that comes into play. And so therefore, actually, and that's why that's an advantage, because it allows you to also adapt to a changing environment. So if you think about Jetsons and the Rosie robot, if it's always doing the same thing that it did yesterday, it's not going to be able to keep up with the world and be able to, therefore, yesterday was a milk spill by the baby, tomorrow it's going to be a broken toy, and being able to adapt as a result. Does that help clarify?
Can I ask a follow-up
Yeah.
question? So it seems like so you want the AI to be adaptive as well as more like sort of like more innovative or creative, right? But like so because my background is not machine learning and AI, but it feels like even with an LLM, like there's no way to explain how the AI can reach give you the answer. So how do you make sure that you keep the AI, the model, to be creative, but at the same time you can't explain how they reach that conclusion, right? So how do you do that?
Yeah. Do you want
Yeah, so I
to
think.
repeat the question?
Oh,
Yeah.
sorry, repeat. why
Yeah,
don't you
so
question?
just repeat the question. Thank you for these great questions. So, with AI, yes, it comes with these generative capabilities that helps with innovation, helps us to adapt, but it is still a black box. So what is the explainability? What can that look like to be able to get us, right, that confidence? Yeah.
Yeah, and this goes into, that's why when you're designing these systems, you want that auditability and traceability at all those boundaries of the agent, right? From the sensors, what information did it pick up from the environment, to what communication protocols in and out with anyone it was interacting, to what its original goal was. So if it was to build furniture or take care of the baby, that was the original goal. And then on the actuator, you are actually delivering some value, right? It could be in a creative way or a more just getting the job done, which is, hey, I'm going to feed the baby and the job is done. Quality of feeding the baby, did the baby finish all 10 ounces of milk or just the 1 ounce and I put it to bed hungry? No one is checking on that, right? So that's where you have to think about the tests and guardrails, and you have to engineer those additional goals in, and you can have other agents that are looking at that traceability of how this one agent is functioning to monitor and say, hey, did Rosie do its job right and correctly, right? Or it could be a human agent, so I could be giving it feedback that, hey, you did a poor job. So it's learning from that first iteration so that the next time the goal is, or the results are better, right? So there's this whole suite of tests you can create with known outputs to train your agent and then give you some of the quality outputs you're seeking. That's just by default machine learning, right? That's how you end up training a machine learning model.
And I do want to add, it is still a hard problem, though. All right, it's there. I think there's a lot. I'm hoping maybe next year at this conference there might be more talks about actually making explainable AI, and because there is a wide spectrum of machine learning algorithms and whatnot, some are more explainable than others. And so I think as we innovate more, even in the algorithms, we might, as humans, trust some algorithms or use some algorithms specifically for certain problems that are maybe higher risk versus low risk, right? Because you want it to be more explainable in certain situations than others. Even for LLMs that you were calling out, the architecture that we're also using with RAGs, right, retrieval augmented generation, also enables a little bit more explainability than before, because you're able to now say, okay, you're able to trace it back to this data source from which I am giving you this answer. So now, even if they're generating, and there might still be some hallucination, you can say, oh, okay, it told me that it generated this answer from this doc, so I could actually double check it. Yes, yes. So I think, and that's where Samia was talking about traceability helps. So I think there's a lot more opportunity for us to do that, but those are exactly the types of, I think, human innovation that we need. So we are being responsible technologists, right, as we build these things through. So thank you so much. I think we are at time, but really appreciate it. I know this is the last talk of the day, and we have the keynote now, so thank you all very much for coming.
Thank you.